Hey, chemistry, Mr. McKee back with the U-try from the stoichiometry and density calculations. This is one of the examples that is in your booklet. So let's get right into it here. If you haven't tried it yet, pause the video and do so, please. Okay, it says, during the Victorian era, diarsenic trioxide was mixed with chalk and vinegar and ingested by women to give them a fashionably pale complexion. How many liters of oxygen, so that's what we're going to try to figure out here, are used to produce 125 grams of diarsenic trioxide? The density of oxygen is 1.438 grams per liter. Okay, so reread the question if you need to. We want to be crystal clear about what we're trying to do and what are the relevant chemicals here. So in this case, we are trying to figure out how many liters of oxygen we have. So I'm going to draw a box around that. That's one of the things that we care about. I'm going to call that chemical B because that's what we're trying to figure out. And we've been given a certain amount of arsenic trioxide. I'm going to call that chemical A. Okay? Remember in our stoichiometry roadmap that this midline separates chemical A, which is always going to be on the left, from chemical B. Okay? So the thing that we've been given goes on the left side of the stoichiometry roadmap. All right? And if we read the question carefully, you see that we've been given 125 grams of diarsenic trioxide. So that is going to go here, S2O3. And we're going to first convert that into moles of diarsenic trioxide. And then we're going to change to our other chemical, the one that we're interested in, using our mole ratio, which is 2 to 9 from the equation. And we're going to convert from diarsenic trioxide to oxygen, O2. Then we're going to have to figure out how many grams that amount of oxygen is. So we're going to convert from moles to grams. And then finally, using density as our conversion factor, we're going to convert from grams of oxygen into liters of oxygen. Okay, so there is our plan, and we're going to refer back to this as we go through here and plot out our solution. So because we're using molar mass for both chemicals, we're going to have to calculate the molar mass of both of these chemicals. So first of all, for diarsenic trioxide, if you add all of that up together, you're going to get 197.841 grams. And if you add oxygen together here, that is 2 oxygens, it's 2 times 15.999, you're going to get 31.998 grams for 1 mole of oxygen. Okay, so we're going to use those as conversion factors. So my starting number and unit, again, is 125 grams of diarsenic trioxide. And we are trying to figure out how many liters of oxygen that is going to need. Okay? So let's go back up to our roadmap. We're beginning with grams of diarsenic trioxide. And we're going to convert that into moles. That is our first conversion here. So for that, I'm going to need to use my molar mass, which is 197.841 grams of diarsenic trioxide equals 1 mole. So that's going to be my first conversion. My second conversion, I'm going to use my mole ratio. To convert from moles of diarsenic trioxide to moles of oxygen. And if I check my equation, I see that for every 2 moles of diarsenic trioxide, I have 9 moles of oxygen. I get that from coefficients. So again, that's 2 moles of diarsenic trioxide equals 9 moles of O2. Running out of space there. And that allows me to change from chemical A to chemical B. Now I'm going to use the molar mass of O2 to convert to grams of O2. So the conversion factor I will use for that is 1 mole of O2 is equal to 31.998 grams of O2. And finally, from my roadmap, I'm going to convert from grams of O2 to volume in liters of O2. And for that, I'm going to get my conversion factor from the problem. I'm going to use the density of oxygen, which is 1.438 grams per liter. So for every 1.438 grams of oxygen, I have 1 liter of oxygen. Okay, now I'm going to plug everything into the train tracks. And I like to start with just the units here. So we're beginning with grams of diarsenic trioxide. And so I should have the same thing in the diagonal down here as always. And we're first converting into moles of diarsenic trioxide. And so I should have that same thing here in the diagonal. And I'm converting from moles of diarsenic trioxide to moles of oxygen. It's my next step using my mole ratio. And I should have that same thing down here in the diagonal so that it will cancel. And I'm converting from moles of oxygen to grams of oxygen. Once again, I should have the same thing down here in the diagonal. And lastly, I'm converting to liters of oxygen. So check it out here, how things can cancel. Grams of diarsenic trioxide cancels. Moles of diarsenic trioxide cancel because they're on top and bottom. Moles of O2 cancel because they're on top and bottom. Reuse my red color here. Grams of oxygen cancel. And I am left with liters of oxygen, which is what I am trying to end with. So that is a good sign that I've set everything up correctly if I'm ending with the correct units. So last thing here is I plug all of this information in. Put in my starting number. And then I put in the molar mass of diarsenic trioxide. And I put in my mole ratio, which is 2 moles of diarsenic trioxide for every 9 moles of O2. Then I put in my molar mass for O2, which is 31.998 grams per 1 mole. And finally, I put in my density, which is 1.438 grams of O2 for every 1 liter. Now I plug this all in the calculator, and the way that I do this is 125 times 9 times 31.998 divided by 197.841 divided by 2 divided by 1.438. Enter. Remember to hit enter only once. And if you do that all correctly, you should end up with 63.3 liters of oxygen. So I just figured out that in order to produce 125 grams of diarsenic trioxide, I would need to provide 63.3 liters of oxygen. Okay, let me know if you have any questions. Thanks for paying attention. Have a great day.